So this is a horizontal map at a given depth, in this case to approximately 1 meter depth of investigation, of all of the survey lines in this area. If we want to look at another depth, this is the top 1 meter. Let's say we want to go down to the 2 meter readings. We can simply plot another resistivity map. Again, sort that map to depth, and select the second receiver, note receiver 2, and again pick up all 21 of those lines. Mark those lines, verify that those are the only ones marked, and simply click OK. And again, that gives us a second map. And what I'm going to do is I'm going to eliminate the color scale to give me a better view of that map. And now we have views of 2 different depth sections. This is of the 1st meter to depth, and this is down to approximately 2 meters. And we can see that although they're very, very similar, we see changes in resistivity as we go down to different depths, which was obvious when we look at the depth sections, because as we're going deeper, we can see that we have different changes in resistivity. The change in resistivity of depth indicates a clear change in geologic structure. We have probably a high clay content material at the surface, a changing from grading from high clay into more sandy material, and the resistive structures here could be voids, or could be, if we were in glacial till, they could be boulders, granitic materials, or something far more resistive than the surrounding clay and sandy soils. Okay, so you can see that we've got horizontal plan view maps, and we've got vertical depth sections. The next step is to invert this depth section to a true depth and a true resistivity. Right now we are in apparent resistivities, and the vertical depth scale is actually an in space. So what I'm going to do is I go to File, and we're going to export this file out to another inversion program called Res2D Invert. And I select Res2D Invert as my export target. I click on OK. And what I'm going to do is, we have data at approximately 1 meter intervals, so I'm going to select 1.25 meters for my data interval. I'm going to average it, and I'm going to give it a position. And I'm going to save this data. And I will call this test line 2.dat. The Res2D software looks for the DAT extension, and I'm going to save it, and OK. So what I've done, I've created an export file that can be inverted in the Res2D software. So now I open up Res2D, I go to File, read the data file, and search for that data set. And I now open test line 2.dat. It reads the data. Now, generally the first thing you'll want to do is actually look at the raw data. So we can go to Edit and to the Exterminate Bad Data Points. And what we see all three lines, this is a single line, all three receivers at different depths on that line. This is our resistivity scale, and 5 meter is the dipole, and these are end space. 1/2, 1, and 1.5. And this data looks very clean, and we have readings at every 1.25 meters along our line. Now what I'm going to do is I'm going to actually invert this data. I choose the least squares inversion. And what we see is it runs through a number of iterations. And this is the raw data. This is the inverted data, and this is the modeled section. So clearly we have a very conductive overburden with a much more resistive basement and some very well-defined, highly resistant bodies at depth. And we're looking down to about a little over 3 meters depth of investigation on this particular line.